Now iodine is formed. Now see, this thyroglobulin also enters the cells. Thyroglobulin, it also enters the cell through the process of endocytosis. So what happens? Endocytosis means the vesicle enlarge and it contains the thyroglobulin. This is, suppose, thyroglobulin. This enters. Now we have seen the iodide which we have taken in food, iodine, which enters into the capillary, converted into iodide, using the sodium iodide symporters entering into the follicular cell. Whatever is formed in follicular cell, it drains into lumen. So this iodide will goes inside lumen by using this transporter present in between the follicular and lumen. This transporter name is pendrin transporter. Now iodide enters into the lumen. Now iodide form enters the lumen. Now what happens? Oxidation reaction will take place. Oxidation means addition of oxygen and removal of carbon dioxide. So what will happen? Now iodide ion will form iodine, because यहाँ से यहाँ travel करने के लिए it need to be get converted to ionic form. Once it enters, it now it again appears in its original form, that is iodine. अब आयोडीन बन चुका है. आयोडीन बना तो अब क्या होगा? आयोडीन इसके अंदर बन चुका है ल्यूमेन के अंदर. Now once iodine is formed, it is converted to ये क्या है? DNA also formed. DNA formed RNA formed protein inside this thyroid gland. So किस तरह protein form होगा? Thyroglobulin. Thyroglobulin also entering the lumen through endocytosis. Endocytosis means ये जो मेम्ब्रेन है ये ऐसे इनलार्ज होकर फ्यूज हो जाएगा, इनलार्ज होकर ल्यूमेन के पास जाएगा, और यहाँ पे जो है ये है थायरोग्लोबुलिन, ये है थायरोग्लोबुलिन प्रोटीन. अब ये यहाँ एंटर हो रहा है, ठीक है. ये एंटर इस तरह से हुआ, ये इसके इनसाइड पहुँच गया. इट एंटर्स नाउ अगेन फ्यूज टू नॉर्मल शेप. ये अपने नॉर्मल शेप में आ जाएगा. Now thyroglobulin is entering inside the lumen. So both of this thyroglobulin and iodine enters in lumen. Now what happens? Process of oxidation will take place in the presence of. So now we have seen the food we have taken. It is rich in iodine. It goes into blood, comes into thyroid gland. Thyroid gland has these capillaries, blood capillaries, entering the iodine into the capillaries in the form of iodide. Ionic form is there to enter the blood capillaries and follicular cells and lumens. So ionic form is required. So once iodine entering the capillaries enters the follicular cell by using the sodium iodide symporter, which is present in the surface of follicular cells. Now once iodide enters, this is called iodide trapping. This is the first step. Now iodine which is entered into the lumen, it enters into the iodide which enters into the follicular cell, entering the lumen by using the pendrin transporter which is present between follicular cells and lumen. Also in follicular cells there is nucleus. Nucleus has DNA. DNA produces mRNA through the process of transcription, and mRNA produce protein. There is the process of translation. So which type of protein will be formed inside thyroid gland? thyroglobulin. Now thyroglobulin is 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 a polypeptide chain. It contains tyrosine, this like this. So by the process of endocytosis, this membrane will budge and it carries the thyroglobulin and entering into the vesicle burst. It forms a vesicle burst into the lumen, and this thyroglobulin enters into lumen like this, and again this membrane fuses. So in this way thyroglobulin enters the lumen. Now inside the lumen we are having both the iodide atom and the lumen, and the iodide atom and the thyroglobulin. This is thyroglobulin. It is a tyrosine. It is amino acid. It has 120 hydrogen. So there will be tyrosine present here like this. Tyrosines are present. Now the iodide which is entered into the lumen by using the peptide transporter in the presence of thyroid peroxidase enzyme. This is enzyme which is required to convert the iodide into iodine. यहाँ पे ज़रूरत था आयोडीन का, आयोडाइड का ionic form में to enter this capillaries, follicular and lumen. Once it enters the lumen, now iodide form is not required. Iodine is formed again by the process of oxidation. Oxidation is basically addition of oxygen, removal of hydrogen in the presence of thyroid peroxidase. फिर क्या होगा, आयोडीनेशन होगा. आयोडीनेशन होगा मीन्स फॉर्मेशन ऑफ आयोडीन. जो आयोडीन है ये कंबाइन होगा थायरोग्लोबुलिन प्रोटीन से, कहीं पे एक के साथ, कहीं के दो के साथ, like this. And so on. Now first क्या था, trapping. Second process oxidation. Third process iodination. Iodine is formed here. Now there will be coupling. So what happens? This tyrosine and this iodine this is called mono MIT. This is called MIT, mono iodothyronine. And this has two iodine, so it will call DIT, di-iodothyronine. Thyroid or tyrosine, whatever you call thyronine. So now what happens, these molecules are formed. This will form a couple, like MIT will form couple with DIT, MIT DIT and DIT DIT. DIT में कितने मॉलिक्यूल्स है, 2 तो कितना होगा टोटल 4. तो यहाँ पे क्या होगा T4. MIT में कितने मॉलिक्यूल्स है 1. DIT में कितना हाइड्रोजन मॉलिक्यूल है 2, तो कितना होगा T3. So now T3 and T4 are produced inside the lumen. It is formed, produced, it will store here. Whenever body needs T3, T4, it will release into the circulation. How it will go to circulation? By the same process of endosis. तो यहाँ पे क्या है, now This is the thyroglobulin. It has T3, T4 on it. Again, with the process of endocytosis, it will enter the lumen. Yes, enlarge होगा. Again ये ऐसे एंटर होगा, फिर ये यहाँ पे आएगा और फिर this T3 will reach here, T3 T4 will reach here. There will be long chain like this. This will enter the follicular cell. Whenever there is a requirement of T3 T4, what happens here, lysosomal enzymes will be present. Also so whenever there is a requirement of T3 and T4, this thyroglobulin attached with T3 T4, this will moves into the circulation. Lysosomal enzymes are also present in the follicular cell and in capillaries. Lysosomal what will do, they will break this thyroglobulin chain with T3 T4, and T3 T4 will be released in circulation. T3 T4 will be free here in follicular cell and it will move into the circulation. Also, like this, by the process of endocytosis, this will enter in the circulation. Leaving here the thyroglobulin and T3 T4 यहाँ पे है. फिर क्या होगा, lysosomal enzyme will break this T3 T4 and T3 T4 will reach in blood, and thus it will go to the, thus it will perform the action of T3 T4. And again, this thyroglobulin at the process of endocytosis re-entering the follicular cell, and again it will available for the next cycle. And this way T3 T4 is formed, and there will be trapping, there will be oxidation. Number one, oxidation. Number one, trapping. Number two, trapping. Number one. Number two, oxidation. Number three, iodination. Number four, release of T3 T4. No, number four is coupling. In oxidation, iodination, and in oxidation, iodination, TP is required. TP, thyroid peroxidase enzyme, is required. There will be coupling. This is fourth stage. Fifth stage is release of T3 T4. Now this T3 T4 is released in circulation. Now T4 is abundant and T3 is less. The ratio of T3 T4 is 14:1. In 1% T3 is formed and 14 times T4 will be produced. Now T3 is the potent form. Whenever we need T3, T4 get converted into T3. T4 converts into T3 whenever there is a requirement. So there is a conversion of T4 to T3. So the whole topic is completed about thyroid hormone. So we have seen there are basically uh, 6 points. 6 points. There is a trapping of iodide. There is a trapping of iodide. There is a oxidation. Number 3, there is a iodination. There is coupling. There is release of T3 and T4, and also there is conversion of T4 to T3. So these are the 6 points to remember for the formation of thyroid hormone. So we have seen everything, the anatomy, the physiology, how the thyroid hormone is produced, how the iodine enters the body, how iodine converts into iodide form, and thus enters from the capillaries into the lumen, into the follicular cells, and into the lumen, and there is a formation of T3 T4. Now the formed this produced T3 T4 release into the circulation, everything we have seen. So these are the basic points to remember how the thyroid hormone is formed. Thank you.